In this presentation, we are going to discuss the paired sample t-test. So here are some notes with regards to that test. Here we have a list of hypotheses for paired sample t-test. The paired sample t-test hypotheses are formally defined below. The null hypothesis, represented by H0, assumes that the true mean difference, the difference between a mean is equal to 0 in the population. So it's a comparison between two means. And the null is saying that there is no difference between the mean of whatever variable in the population. Now you've got the three alternatives: the two-tailed, the upper-tailed, and the lower-tailed. So the two-tailed is saying that the difference is not equal to 0. The upper-tailed is saying that the difference is greater than 0. And the lower tail is saying that the difference is less than 0. So let's look at when to apply the paired sample t-test. Now we have some idea as to what the hypotheses are about. And as we can see, we have an idea. It's comparing the means of two different means. But let's get some more specifics. It says a paired sample t-test is used when we are interested in the difference between two variables for the same subject. So two means, but for the same subject. Often, the two variables are separated by time. So it's like a before and after. So for example, in the Dixon and Massey data set, we have cholesterol levels in a time before 1952 and cholesterol levels after 1962 for each subject. So therefore, every participant must be measured twice, before an intervention and after an intervention. That's why it's called paired sample t-test as compared to independent sample t-test, where you have two independent groups. Here you have a single group and two measurements are taken from each participant in that group. So now we are going to take a second look at the hypothesis in symbolic form. So the null will be saying that there is no difference between the means, that the difference between them is equal to 0. Then you have the three different versions of the alternative hypothesis. You have the two-tail, where the alternative is saying that the means are not equal to each other. You have the upper tail, which is saying that the difference is positive, it's greater than 0. And you have the lower tail, saying that the difference is less than 0. So here we are going to discuss a case scenario. It says an investigator wants to evaluate the efficacy of an acupuncture treatment for reducing pain in patients with chronic migraine headaches. The plan is to enroll patients who suffer from migraine headaches. Each will be asked to rate the severity of the pain they experience with their next migraine before any treatment is administered. Okay, so you can actually sense the sequence of time before administering the treatment. Now, pain will be recorded on a scale of 1 to 100, with higher scores indicative of more severe pain. Now, each patient will then undergo the acupuncture treatment, and on their second migraine post-treatment, okay, so you have a pre-treatment and a post-treatment. Each patient will again be asked to rate the severity of the pain. Okay, so you're going to take two measurements from each patient, pre-treatment and post-treatment. So that's why they call it paired sample t-test. The difference in pain will be computed for each patient. A two-sided test of hypothesis will be conducted at alpha 0.05 to assess whether there is a statistically different or statistically significant difference in pain scores before and after treatment. And you need 15 units to do that. So that's a paired sample t-test. measuring the effectiveness of acupuncture treatment for migraine headache. So two measurements will be taken before and after treatment, pre and post. So here we are going to complete the research topic, which is anything along the line of acupuncture and migraine headache. Then the research question is acupuncture an effective treatment for migraine headaches? And the hypothesis, which is a claim, an answer without empirical data to the research question. Acupuncture is an effective treatment for migraine headaches because the difference in severity of the pain before, that is pre and after, which is post treatment, is not equal to 0. And the objective, well, objective is only one research question, one hypothesis. One objective is to determine if acupuncture is an effective treatment for migraine headaches. Now, if you notice now, population is written because all these, the research question, research topic, research question, hypothesis, and objective are all geared towards the population. Now we have to take a sample now to test these hypotheses. Is acupuncture really a treatment? Is that true? Which is saying that the treatment is effective. So let us get some data to prove whether or not what is said about the population is true. So let's take a sample of 15, which is what was stipulated initially. So to test this hypothesis, this claim made about the population, we have collected a sample of 15 data before, that is pre-treatment, and after post-treatment, meaning after the acupuncture, before and after the acupuncture treatment was taken. So now we need to input this now in an online calculator. But before we do this, let us outline the steps for a p-value approach. We first have to state a pair of hypotheses in symbolic form. And here is the pair. The null will always be saying that the difference in average is equal to 0, that there is no difference. And for this, it's a total. So the alternative is saying that the difference is not equal to 0. So that's step number 1. Step number 2 is to input the data in an appropriate calculator. So we need a paired sample t-test calculator. So we can go to Statistics Kingdom, paired t-test calculator, dependent t-test. Here it is, paired t-test. So we can click on it. And it says go to calculator. Let's go to the calculator. And here we can input our data, enter raw data directly before and after. Pre-treatment, and post-treatment. So let's just copy and paste the data. So here it is, pre and post-treatment. Entered raw data directly. Now to calculate, well, let us check what our significance level is, 0.05. Okay, so let's keep it that way because it comes with that by default. So let's calculate and let's go to the next step. It says identify the p-value, which is the judge. So we can just copy the output. So we can clearly see the p-value is 0.001459. Now let us recall the decision criteria. If the p-value is less than the significance level alpha 0.05, we reject the null statement, the null hypothesis. If the p-value is not less than the significance level, if it is greater than the significance level, we do not reject the null hypothesis. So therefore now our p-value, which is 0.001459, is less than the significance level. So the null has to be rejected. Because the p-value of 0.001459 is less than the significance level of 0.05. So now our conclusion says that if the null hypothesis is rejected, the alternative is the conclusion. If the null hypothesis is not rejected, itself is the conclusion. So therefore, the null hypothesis was rejected, the alternative statement is the conclusion. The alternative statement is saying that the difference is not equal to 0. In other words, the acupuncture treatment was or is effective. The difference is significant. And if you take a closer look at the data, you can actually have some suspicion to that. Before the treatment, 80, after the treatment, 61. Before 99, then you have 89. Before 78, then you have 70 after. 45 before, 23 after. So you can actually already suspect reduction in the severity after the acupuncture treatment was provided. And the test actually confirms that. And APA style is written in green here. Results of the PET test indicate that there is a significant large difference between pre-treatment and post-treatment. Pre-treatment, you have a mean of 66.7. Post-treatment, you have a mean of 56.63. There's a significant difference according to the test.